Okay, we're continuing on with our learning of radical equations. Last lesson we just learned how to solve them and check for extraneous solutions. Now we're going to have variables on both sides of the equal sign and how we solve those. Previous lesson we just had a variable on one side of the equal sign. So things are getting a tad bit more complicated, but still, you guys will do awesome. So if you remember, yesterday we learned to get all the variables on one side of the equal sign or the radical on one side of the equal sign before we square both sides. We can't quite do that this time because we have more radicals or more variables to work with. So here we're going to be foiling more and just working a little bit harder for our solution. So let's go ahead and try the first one. So let's keep the radical on one side of the equal sign here and move the x. I don't know why I wrote 2. That's hilarious. Now I'm going to square both sides, and I'll be foiling the left, so you really have 6 minus x times 6 minus x equals the square root of x squared. So it gives 36 minus 12 x plus x squared equals x, because the square root of x squared is just plain old x. Let's go ahead and get all of the variables on one side, 0 on the other, so I have x squared. I'm going to subtract an x from both sides. That gives us minus 13x plus 36 equals 0. Okay, so we need factors of 36 that add to give us 13. How about x minus 9 and x minus 4? So x equals 4 and 9. We do need to check for extraneous solutions, so I'm going to put my my answer back in here. 6 equals 4 plus the square root of 4. 4 plus 2 equals 6. We're good here. That's a check mark. 6 equals 9 plus the square root of 9. 9 plus 3 equals 12, which is not equal to 6. So 9 does not work. X equals 4 is my only solution. All right, let's try a few more. Again, I'm going to try to get the radical by itself and everything else on the other side of the equal sign before I solve. So I have 3x minus 1 equals 2 square roots of x. Go ahead and square both sides. Here, on the right side, this 2 is outside the radical. So when I square the square root of x, I get x. When I square 2, I get 4. Something to pay attention to. So on the left, I have 3x minus 1, 3x minus 1. That's somewhat illegible. 3x minus 1, 3x minus 1, and on the right, just plain old 4x. So here, if I FOIL this, I get 9x squared minus 3x plus 1 equals 4x. 9x squared minus 6x plus 1 equals 4x. Go ahead and solve. 9x squared minus 10x plus 1 equals 0. Now we need to factor this. To factor, I have, we're just going to ignore this from now, I'm going to have to move it. To factor, I have, 9x minus 1 and x minus 1. Let me check that. I get 9x, negative 9x, negative 1 gives me negative 10, and positive 1. Okay. That one was hard for me to factor for some reason, but we're good. So x equals 1/9 and x equals 1. Let's go ahead and check our answers. If we do 1/9, 3 times 1/9 equals 1 plus 2 square roots of 1/9. Square root of 1 over 9 is 1/3. Times 2 is 2/3. Plus 1 equals 1/3. 1/3 is not equal to 1 2/3, so 1/9 does not work. Let's try 1. 3 times 1 equals 1 plus 2 square roots of 1. 3 equals 1 plus 2. We're good. 1 works. Okay, let's try this one together, and then I'll let you do the next two on your own. Go ahead and add x to both sides so that we can square both sides. So I get 3 plus x equals 16x. This gives me 9 plus 6x plus x squared. Go ahead and get everything on the same side of the equal sign. Subtract 16x, I get negative 10x plus 9, which x minus 1, x minus 9, x equals 1 and 9. Let's go ahead and check them. 3 equals 4 square roots of 1 minus 1. 3 equals 4 minus 1, that works. 3 equals 4 square roots of 9 minus 9. 4 times 3. 12 minus 9 is 3. They both work. Awesome. Okay, why don't you go ahead and try these on your own. I'm probably going to have to move number 4 to a new slide, but go ahead and try them, and we'll check our answers in a few minutes. Okay, here's the solution for number 3. Go ahead and check it out. And we'll move on to number 4. Okay, I'm pushing pause. Check it out. Okay, I'm going to work on number 4 now, but go ahead and push pause. See what you do with this one. It'll be fun. Okay, with this one, you actually could have figured out that it was impossible right up here. I will never be able to take the square root of a number and get a negative on the other side. I went ahead and went through with the math, got x equals 39, plugged it back in, and we're just done. It's no way it's going to equal. It's a no solution problem. Okay, let's try another one. Solve this equation. Okay, this is where we need to do a little bit of maneuvering of our stuff. I still want like radical on one side, and I'm going to move the other radical over, and I hope you see why. If I have the square root of x plus 3 on one side and then 3 minus the square root of x on the other, it's just going to be a little bit easier to try to get the two equations, try to eliminate the radical and work through the problem. This one's going to take a few steps though, so if you think that you're ready to go ahead and start the classwork or the problem set, I'd watch this example first. I don't know why I'm in red, so let's go ahead and work through this problem. Like I said, we're going to do x plus 3 on one side and 3 minus the square root of x on the other. And I'm going ahead and square them. And I will have a radical still, but you'll see what will happen. FOIL this, I get 9 minus 6 square roots of x plus x. Let's go ahead and subtract x from both sides, and I get, those cancel out. Minus 9 minus 9, I have negative 6 equals negative 6 square roots of x. Let's go ahead and divide those, that makes sense. Square root of x equals 1. See, I'm not done yet. I still need to square both sides, and I get x equals 1. And that's how these problems are going to work. Sometimes you will not be able to get rid of the radicals on the first try. You'll have to isolate the radical again and then square everything a second time. Let's go ahead and check our work though. I have square root of 1 plus square root of 1 plus 3 equals 3. 1 plus square root of 1 plus the square root of 4, 1 plus 2. Perfect. Okay, let's try these. There's two of them here, number 5 and number 6. I'm going to do number 5 with you together just to make sure that we understand everything, and then you can try number 6 on your own and check the solution. So I'm going to go ahead and move one of these radicals over to the other side of the equal sign. It does not matter which one. X minus 3 equals 4 minus x plus 5. Oops. Makes me laugh when I do that. I say one number and I write another. Now let's go ahead and square both sides. So on the left I have x minus 3, and on the right I have 16 minus 8 square root x plus 5 plus x plus 5. Let's go ahead and collect like terms. X minus 3 equals 21 plus x minus 8 times x plus square root of x plus 5. Subtract 21 from both sides. I have negative 24. The x's cancel. Negative 8 times the square root of x plus 5. Divide both sides by negative 8, and I'm left with 3 equals the square root of x plus 5. Let's go ahead and square these again. Get 9 equals x plus 5, x equals 4. Let's check it though. 4 minus 3. Oops. Let's try that again. 4 minus 3 plus 4 plus 5 equals 4. 4 minus 3 is 1. 9. So 1 plus 3 does in fact equal 4. Yay! All right. Okay, why don't you guys go ahead and try number 6 on your own. I'm going to push pause and work on it myself. Awesome, there we go. We are complete. Good job today. Last slide. Okay, let's summarize what we've done. So basically, if a equals b and n is an integer, then you can raise both the left and the right to the same integer, and you can solve the equation. It's a valid algebra move. However, the converse is not necessarily true. So if you have a to the n and b to the n, it does not imply that a equals b. We have some negative issues, we'll get some extraneous solutions, so it's really important to check our answers at the end when an equation is raised to an exponent. Good job today.